Okay, so a street light is at the top of a 13-foot tall pole, and a woman who is 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of her shadow moving when she's 30 feet from the base of the pole? So this is a related rates problem. We're going to start by drawing a picture, which I have here. And you can see my light is over here on the left, just 13 feet tall. The woman is 6 feet tall. She's in the middle. And then her shadow down here is formed by drawing a straight line from the light source to the top of her head, and then just continuing that down until you hit the ground. I'm also just going to add an arrow here to show that she's walking away from the light post instead of towards it. Now, we also need to add in some variables. The first of these is going to be x, which is going to be the distance between the light post and the woman. And I'm also going to add a variable z, which is going to stand for the distance between the light post and the tip of her shadow over here. So let's make a note of what those are. And we're also going to make a note of what the actual values of these two variables are if we know them. So in this case, the problem tells us that she's 30 feet from the base of the pole. So we're just going to note x equals 30 feet. Okay, so related rates problem, which means that we need to not just account for the x and z variables, but also remember that we need to be taking the derivative of these, right? So we're going to look at not just x, but dx dt, which is the speed of the woman in feet per second, and not just z, but dz dt, which is the actual speed that the tip of her shadow is moving. So we know that dx dt equals 5 feet per second because the problem tells us. And we don't know what dz dt is, but we do know that's the information that we're looking for, right? That's what the problem is asking us for. So now that we've done all that, our next step is going to be to write an equation that relates all of these variables together. And in this case, I'm going to do that by using similar triangles. So you may notice I have a smaller triangle over here, which is formed by the woman in her shadow. And then I also have a larger triangle on the outside, which is the one formed by the light post all the way to the tip of the shadow again. So this is like I said, it's similar triangles. So we can write this as a ratio. On the top here, I'm going to have these smaller triangle values. So 6, which is her height, and then the length of her shadow, which I'm going to call z minus x. And then on the denominator, I'm going to have my larger triangle, which is 13 by z. So my equation's all set up. The only thing I want to do now is simplify it a little bit so that my z's are all on one side and my x's are on the other side, just so it makes it a little bit easier to take the derivative when we come to that part. I'm going to go ahead and just multiply both sides by z here just to remove it from the denominator, which gives me 6 over 13z equals z minus x. And my next step here is going to be to move the z over on the right-hand side over to the left. So I'm just going to subtract z from both sides, which gives me 6 over 13z minus z equals negative x. And I want to simplify the z's on the left-hand side. So what I'm going to do is just change the numerator. I'm sorry, not the numerator, the coefficient of the second z here from 1. And I'm going to rewrite that as 13 over 13. So now I have 6 over 13z minus 13 over 13z. And my right hand stays totally the same, equals negative x. My last step here is I'm going to go ahead and simplify. So 6 over 13z minus 13 over 13z is going to give me negative 7 over 13z on the left. Keep our negative x on the right. And our very last step is just to remove the negatives from both sides. So what I'm going to do is divide both sides by negative 1. So negative 17 over 13z divided by negative 1 becomes 7 over 13z, and then negative x becomes x. So this is my final equation. What I'm going to do now is, remember, we're interested in the related rate, right? We're interested in the rate dz over dt. We're not there yet because all we have in our equation here is z. So what I need to do to get it from z to dz dt is take the derivative of the entire equation with respect to time. So I'm going to go with a d over dt of the whole equation, 7 over 13z equals x. So what this is going to give me is 7 over 13. And then when I take the derivative of a variable with respect to another variable, it just becomes d of that initial variable. So in this case, we're going to have dz on the numerator. And then I just keep the dt. So this becomes dz over dt, and x becomes dx over dt. Now remember, what we're interested in is dz over dt. So I'm going to go ahead and solve this for dz dt. I'm going to multiply both sides by 13 over 7, which cancels out on the left, and gives me dz over dt equals 13 over 7 times dx dt. And then I'm going to go ahead and fill in my dx dt value, which we remember is 5. So dz dt equals 13 over 7 times 5, which gives me dz dt equals 65 over 7, or 9.3 feet per second. So the tip of her shadow is moving 9.3 feet per second when she's 30 feet from the base of the pool. And that's it. We're all done.